All right, almost time. 5, 4, 3, 2, 1. Hello and welcome. We should be live now. Hope everyone is doing well today. I'm excited to be here today with Cale Teeter, Senior Software Engineer on the blockchain team. And the stream for today, we're going to focus first on building an Ethereum logic app.
Hopefully we get a good crew here today again and talk about some blockchain stuff.
I'll just wait a few minutes as folks are still joining. But Cale, how are you doing today? Everything is good. Awesome. Well, it's great to have you back again for another blockchain stream this week. This is now our third blockchain stream of the week. In previous streams, we've covered some different topics like the blockchain development kit, Azure Blockchain Service, Azure Blockchain Workbench. So today we're coming at you with a little bit of an exploration into an Ethereum logic app, and then some other topics around building better smart contracts and applications. So really the goal of today is just that you learn something new and exciting. Of course, we want you to interact with us. So like always, ask as many questions as you like in the chat, and we'll be sure to get to them. So yeah, pop in, say hello. We're excited to get started. I see one comment so far that says that we're lagging some. So let us know how that goes. Of course, let us know if you can hear us and see us and everything. But yeah, I think we can go ahead and get started for now, and I'll just keep an eye on the chat. So yeah, again, in this stream, we have a great agenda lined up where we're going to kind of just start exploring what are logic apps, how are they relevant to blockchain. We're going to kind of then deploy a simple smart contract, then build a logic app. And then after that, we're going to start to explore some other helpful topics, like I mentioned, around smart contract development and deployment. So I think that is about it. I do see another comment that audio is lagging. Sorry about that. I'll just keep an eye on it. I'm not sure if there's anything that we can do about it for now. I'll just try to talk slow. Maybe Cale and I could both talk slow. Just, yeah, let us know how it works. But yeah, I think for now, let's just kind of start for this stream and just kind of start and talking about what are logic apps. So some of you might be familiar with logic apps. The idea is that there are low to no code solutions to kind of create these workflows in a nice visual way. So I guess let's just kind of have a conversation first.
I think,
how are these logic apps relevant to blockchain-based workflows?
When people build smart contracts, they deploy them to ledgers like we showed in some of the previous streams we did. Then the next step, obviously, is, hey, I actually want to use this thing inside of an application. And that can be a daunting task because you have to get used to some new libraries to talk to things like RPC endpoints, which is primarily how you communicate with an Ethereum-based blockchain. And so one of the goals of what logic apps, which is basically a serverless type technology that Microsoft has kind of pioneered, is to basically lower that bar to entry, to make it super easy for people who want to come in and do things and not have to be like a really hardcore developer or devote a lot of time to learn a bunch of APIs in order to get that stuff kind of set up. So you can certainly still do the hard way, right? You can still go build your dApp from scratch using Web3.js or Web3j or any of the popular frameworks out there. But this is kind of like making it into like an API. So primarily you'll end up with a REST API here that allows you to both like read data from a smart contract, but also write data to it and then obviously react to events and things like that coming off of it. So that's kind of what we were going after here.
Awesome. Thanks, Cale. And it looks like your audio is coming in very clear, so that is good to know. But yeah, thanks for explaining a little bit about logic apps and kind of how they're relevant for Ethereum. Let's maybe explain a little bit about how can the dev kit in particular help to build
we're still
these
trying
types
to
of
kind of figure out some of these pieces, right? So on the logic app side, what we've added into VS Code for the IDE is the ability for you to say, hey, when I build my smart contract, instead of me having to go define a bunch of stuff inside Logic App to be able to see like what functions are inside of my contract and be able to wrap those with an API, that's really what added in. So we have like a little code generation tool, if you will, built into the IDE that allows you to say, hey, once I define my contract, I can right click on it, I can generate a stub Logic App, and I can take that to Azure.
Awesome. And we'll get to see that in just a moment as we transition to the demo. I think one other question that I have for now is just if you could tell us a little bit about the difference between Logic Apps and the Blockchain Data Manager in particular. And it might help to explain a little bit about the Blockchain Data Manager.
On the Data Manager side, we again spoke, and I think even Meaghan did a cast yesterday on this as well. But basically, Blockchain Data Manager is a service that runs as part of Azure Blockchain Service. And essentially, that ledger that's running behind the scenes there, once you deploy contracts to it, you can create what's called a Blockchain Data Manager application. And what a blockchain data manager application is the definition of your contract, right? So you take your contract ABI, which is your application block interface that we use to integrate our code with our smart contract, and you take the binary file, which is the compiled version of your smart contract. You give that to BDM, and you say, hey, if you ever see stuff happen with this contract, let me know about it. From a high level, that's kind of like what BDM is focused on. And then essentially, sorry, go ahead. No, I was going to say then basically it's like an abstraction there that allows you to attach like event grid to it, and then you can attach legacy systems. We always show Cosmo DB, but you can attach all kinds of different things up there to make that useful. The watcher, the component, so there's something running in the background as part of that service that's watching basically the Ethereum blockchain for events specific to the one you told it you're interested in. That's the core of what BDM's about. To contrast that a little bit with what a Logic App can do, because a Logic App can also react to events, and we'll show a little bit of that here today. It's not a running service the same way, right? So in that way, we're basically wiring up a different component. We're basically creating like a mini watcher that's going to run as a serverless application up here, and that's going to give us this kind of feedback. So they kind of accomplish something similar, but in a different way.
Yeah, I think that makes a lot of sense. And yeah, we'll definitely see this as we transition into the demo. But I think as I've been exploring the Logic App connector myself, I find that there is maybe just a little bit more that you can do with it. And kind of like you're mentioning, more that you can do to kind of execute the smart contract, as well as other actions that you can kind of take to deploy or get the smart contract state or so on. So I think there's just more options there. So I guess maybe now let's go ahead and transition over to the demo itself and kind of get this started.
Okay. So what I have here is a basic project. We went through these in other casts, but if you're just catching up with us now, basically you'll need to install our extension, the Blockchain Development Kit.
So
just search for blockchain.
Able
if you click
to
on this little icon over
code
here.
Now.
Once you have that installed, then you can basically create a project, and all you have to do is bring up your command palette. For those who don't know, view command palette. Once you're in there, you can type blockchain, and you'll see a bunch of commands, and one of them is a new Solidity project. That's what you see here, basically. So I have a Solidity project. It takes a few minutes because it installs a wallet and does some things there for you. Once I did that, I customized this a little bit. By default, you'll get a hello blockchain. So I just deleted that and something for this demo that just makes it a little easier for us to focus on what we're trying to show here, which is how to interact with a contract through this API, and then how to read events and things like that. So in this contract, it's called Simple Storage, and basically it just has a single variable that's going to store our state. It happens to be a number field. We have an event here that's defined in our smart contract that basically is going to keep track of our old value and our new value. our constructor here is basically going to, basically set this to a number 7 by default, and then we have getters and setters. The getter obviously just returns the stored value. The setter, when it does set it, it also calls this event. So it updates the value, and then it also calls this event, so it triggers an event. And we'll use that a little bit later. But if we just take a look at this, like running locally here. Actually, I have this deployed out to the Azure blockchain already. So if we drop to a command line, and Meaghan, I just want to double check. Can you guys see my screen totally? It's not being cut off? Okay, great. Yeah, the last stream we had some issues with like cutting off, so I just want to make sure we're good. So just let us know in the chat window if anything's wrong. Basically, what I'm going to do is attach to. I've already deployed this out to the Azure
let us know
blockchain.
If you can see everywhere.
But basically, I would show you. You can just use this truffle console -- network. You can open up your truffle config and you can grab whatever yours is. Now, remember from a previous one that we registered our Azure Blockchain Service down here. That's what's defined here. So you'll have to deploy this out to something public. You can't do it locally, obviously, because the service on Azure is going to need to pull it, and then you would have to open up ports on your machine and all that stuff. So the best way to get started with this is create an Azure Blockchain Service, connect to it here, scaffold out this project, and then do what I'm doing right now. I just copy this guy. We'll attach to our network here. Yeah, and then we can say simple storage, not deployed. Again, you can just look back at a video, or we can put this on GitHub if you like. I'm just doing some commands here. So basically what I'm going to do is call the get function. And for guys who are new to this, or people who are new to this, you might see like some weird stuff come back like that whenever you do stuff. And that's just a formatting thing. So the number, my constructor set it to 7, but earlier I was playing with it, so I set it to 42. But if you want to make it look actually pretty, you can do something more. So you can say, hey, return to number. And then you'll see just like a simple number 42. And we could call the setter function. Let me pull the contract up here so you know what we're doing. We just called that get function right here. Like I said, it's set by default to 7. I was messing with it earlier. That's why it's set to 42 right now, but we can change that to whatever value. And you'll see whenever we trigger it through the interface, I want to show you that we can actually read it so you know it's not fake here, what we're doing. So basically, right now it's reading. Yes. Yeah, sure.
Mm-hmm. And could you pull your terminal up a little bit, Cale?
Okay. So basically, I just read the value. The value was 42. Let's go ahead and do some other things. So now I want to use a logic app. How do I do that? Well, one of the things you can do is just right-click on the contract that you want to wrap with a logic app, and you'll see we have these 4 options down here at the bottom. This is context sensitive, so you have to have a SOL file, like a Solidity smart contract. We have data publishing here, which basically allows you to essentially create a SQL table that corresponds to your state variables if you want to like synchronize your smart contract to like a database, for instance, for analytics or something like that. We have an event publishing one that basically looks at the events you have defined in your contract, and then we'll essentially wire those up, just like BDM we were just talking a minute ago, so you can like put those into a workflow that allows it to trigger, you know, an event that gets created on Service Bus or Event Grid, and then you can consume that in your other application. We got a microservice one, which is the one we'll use here first, which basically wraps all the functions inside of your contract and allows you to call them through a simple REST interface. And then we have a report publishing one, which kind of ties along with the Power platform. So we have this, in Microsoft, we have this service called Power, which is like Power BI, Power Apps. There's a whole bunch of these things as part of the Power platform. It's a low, no-code tooling to build like mobile applications, desktop applications, all that kind of thing. It also has reporting kind of functionality in it, and that's what this one's targeted at. If you're interested in these, those can help you do that. But if I do a generate microservice contract, basically what it's going to ask me, do you want to create a logic app, a flow app, or a function? For this demo, we'll do the logic app just to show what it looks like. A flow app is basically another platform we have, which is part of kind of like that Power Platform, which allows you to, without any development experience, be able to create a serverless application. And then an Azure Function is kind of lower level. That's basically a logic app sits on top of Azure Functions. So Azure Functions are just like you could write some C# code, some Node.js code, some Java code, and you can run it as a serverless app up there. Logic app is basically layering a UI on top of that for you to make it super easy for you to use it.
That's a helpful distinction to know. Sorry to interrupt, Cale, but I think that's the difference, right? And you kind of just explained that clearly, but like, why would I, maybe want to use a logic app as opposed to a function? I think it depends on like the amount of code that you actually want to write for this, right?
That's right. And obviously, like when you're writing no code, there's more limitations put on you, right? So an Azure function is very flexible, right? You can do all kinds of things with it. A logic app has connectors, we call them, that plug into that, and they only offer certain functionality, right? So obviously it's there to make things easier, but you can't solve everyone's problem. So that's kind of like the issue there.
Right.
So the next thing it's going to ask you for here is a contract address. Now, the first time you do this, you might be like, what the heck is that? How do I get my contract address? So a couple ways you can get this. I'm going to escape out of this so we can show you what this looks like. But when you deploy something up here to the Azure Blockchain, and I don't have my deployment logs here, but I could rebuild. Let's go ahead and redeploy this once. When you deploy something, and I'm just doing it locally, we could have deployed it to Azure as well. If you go into this output window as part of your terminal, and then you select Azure Blockchain over here in your list of things, you'll basically see the logs coming out of here. You'll see the migration going for our demo here, and then you'll see simple storage is the one that I was defining here. And right after that, you'll see like a contract address. So every time, keep in mind, you make a change to your contract or you redeploy it, you're going to get a different address, right, every time. And so it's important for the logic app, obviously, to know which instance we're talking to. So it needs to know the address. If we make a change to the smart contract, we redeploy it, the address changes, we have to change our logic app. So that's one thing to kind of think about. That's also an important distinction between BDM and logic app. Logic app needs to know the address, BDM doesn't. Because what BDM's doing is looking at your actual binary code and saying, hey, if I ever see this thing being used, then trigger it. It doesn't matter if there's like different instances up there.
Good point, yeah.
So we can get the address here, but we also put something that's kind of like an Easter egg here a little bit. It probably doesn't get enough press, but if you open up your build folder after you do a deployment or a compile, if you right-click on these output files, we got all this kind of nice stuff over here too. So basically you can copy your bytecode if you needed your bytecode for something, either the constructor or the transaction bytecode. For this demo, for the logic apps, you would always use like the constructor. The reason we added this transaction one was for BDM. So BDM, to tell you, maybe we'll just go click down. This is kind of for the geeks here, but if you have a smart contract that links to a library, or smart contracts that call other smart contracts, basically they only get injected at deployment time. So the compiler says, hey, there's another contract that I depend on. I need to basically link to that thing. And the linking happens at deployment time. So constructor wouldn't have it. It would just have a placeholder in there. Transaction would have the real one.
That's really helpful to call out that distinction too. I think it could be a little confusing to see, these two bytecodes and know what the difference is between them or when you need to use which one.
Yeah. And the ABI is always the ABI, so you don't get lost with that. And these basically copy to your clipboard. So if you needed that ABI or any of that kind of stuff, you can get it there. If you need the address, you can come down here and get this kind of interesting thing here. So let's go back to what we were doing. Pick a logic app. Yeah, we'll go ahead and put this one in. It's fine. This one wouldn't resolve, by the way, because it's local. So this doesn't exist up in Azure, but it's okay. And I probably will just escape here after we're done. So it's going to ask you your subscription that you want to actually deploy this to.
Sorry, Cale, I think at the end of that, you had some extra text there.
Okay.
So
no worries.
Okay.
Yeah, it's a good point. You got to make sure that you don't have anything extra in there.
There we go.
Yeah. And then basically whatever Azure account you're logged into, if you're not logged into Azure, obviously it's going to prompt you with a little notification. You can log in, you'll see your Azure subscriptions. In my case, I'll pick the Sandbox, and I'll pick this Logic App group over here. Now, I already created this, so I'll show you what happens. Basically, you get this little folder here, and you'll get simple storage, which is the name of our contract, and then inside of there, you'll get anything that you generated for it. So the service one is the one we're going to walk through here first. And if you look at, like, basically, here's the set function, which we'll call to basically trigger that set piece that we had there before. You can see it's just a bunch of JSON in here. And basically, this is what the code generator is doing for you. It's going and looking at your smart contract metadata, like basically the AST, the tree of information behind the scenes inside your smart contract, and it's generating wrappers for each one of those functions. Now, in this case, we only had 2 functions. We had a getter and a setter. If you had more would show up here, right? If you had 10 functions in there, 10 things would show up here. So you can choose like which ones you want to use, kind of granular. Basically, you see it injects like your contract address. That's why we ask you for that, things like that you're going to use. Now, what you would do at this point is you would basically select all this and you would copy it, and then you would go up to Azure. Now, I have one here together, but if you didn't have one, what you would do is go into a resource group, and inside your resource group, you would add a resource and you would add a logic app. Now, when you add logic apps, by default, you'll hit create. It's not going to ask you for much info, and I think Meaghan went through this in her session as well. It doesn't ask you for much here, right? Basically, your subscription, what resource group you want it to go to, what do you want to name this thing uniquely, what region you want to deploy it to, and then if you want some advanced analytics and things like that turned on for it. So super simple, but once you get that set up, you're basically going to be left with a clean slate. In that clean slate, actually, maybe it makes sense for me to just do one from scratch so you can see that.
Sure.
So let's.
And are you just going to start from a completely blank logic app?
Yeah.
Okay,
I have
cool.
some pre-built here to save time, so just so I don't have to fumble around typing stuff that I usually mess up. But yeah, I'll walk through it and then I'll show you the completed one. And these usually take just seconds. These aren't like a 10-minute thing, so you'll see these go really quickly. Because it is serverless technology, it really hasn't done much other than a definition at this point. As I mentioned before, like Logic Apps is a platform that has tons of other connectors you can explore up here. There's all kinds of pre-built ones up here for you, like workflows. Here's some of those connectors I was talking about. And what we've done is added some specific ones for Ethereum. So that you can use those. So you would click on blank logic app to begin with, and you could build stuff by scratch here, like if you wanted to go build all this by yourself. But again, it's we're kind of lazy. Like we just want to get stuff done. We don't want to spend time doing this. So by default, we would just like wipe out what we have here in our logic app. We would grab this definition that we built, and then we would do a save here. Now, once we do a save, you'll click on this little designer thing here. Hopefully everybody can see that. And it'll render what we saw inside of that JSON file. So these are our connectors I was talking about before.
Nice.
So again, you could go build them, but why you want to do all this stuff, we just did it for you straight out of VS Code. You'll see that we have basically an HTTP endpoint that's going to listen, and here's the actual URL it's going to listen on. You'll see that it's going to accept one parameter called new value. And for those who were paying attention over here, in the simple storage, if you look at the set function, the parameter we pass in is new value. So it's basically showing it's actually read the whole thing and it knows it's looking for this. Now it does pass everything over as a string as part of the HTTP call. It doesn't know the concept of a number or anything at this point because it's just JSON. So in this case, it's a string, but that's no big deal. Here you can see a little Ethereum diamond in our connector, but you'll see by default you get this little traffic sign over here that says something's wrong. And basically it's saying you don't have a connection. So what we do is build the connection object for you, but obviously we don't know your blockchain, like any keys on your blockchain that you're using. And so as part of that, basically you'll have to enter that stuff. Now in my case, I already defined one, and it's here. And maybe I should, let me try something else. Let me cancel that because I want to show you what it looks like to create a new connection, because you'll be experiencing this too. So I already had one defined, but if you hit add new here, basically what you're going to be asked for is a few pieces of info. And some people get hung up on this and they have problems. So one of the first things is a connection name. You can just name that whatever you want. For some reason, I always call things main, but you can call it whatever you want. It's your definition. Next thing it's going to ask you for is your endpoint, for the RPC endpoint for your Ethereum. Now, in our case, we're using Azure Blockchain Service. So I need to pop open the Azure Blockchain, I'll pop open the portal here so I can get some info from it. So I'll open up a separate tab here, and we'll just go into my same Azure subscription. We'll basically go in here, and we'll go into our Logic apps. Oh, actually, I'm going to go into this one, which is my ABS instance. There's my Azure Blockchain Service. Again, you can create that from inside the IDE or here in a portal. It doesn't matter either way. First thing we want to go after is the transaction nodes over here in the left nav. When we go in there, we'll have any of our transaction nodes listed. I just have one. And then we'll click on this access keys option here. When we click in here, we got a whole lot of different access keys we can use. I'll take this one. And basically, that's all I need is to plug into here my RPC endpoint. Next step, this is where people get hung up. So it's asking for a private key, an account address, and a password. So if you're deploying to like other things beyond like Azure Blockchain Service, you'll probably use this private key option, which basically means you'll go onto that node, you'll create a key pair, and you'll get the private key, you'll export it from there, and you have to enter that here. And that's what we'll use to sign transactions that are coming through here. If you're using Azure Blockchain Service, we make it a little bit easier. So what I mean by that is, if we go back here to our Azure Blockchain Service, you'll see up here at the top we have some things. One of them is a member account. So by default, on the first transaction node that we create in Azure Blockchain Service, we create an account on there. And this is the account. This is the address for it. So if you copy this to your clipboard, you bring that guy over as your account address. You can put that there. I don't know why they put.
Oh, that's weird.
Yeah. I don't know why that did that. That's weird. And it's stuck there now. I don't know why that's doing that, but okay. And then you would put your password in, whatever your password was that you created when you started. Now, I'm going to cancel out of this. This is where I'm going to flip over to one that I already have running, so we don't have to watch me fumble copying, pasting things. And we'll just go into this one. And we're back in the designer, and you can see this one's all filled in. Now, once you've authenticated like to your cluster, or like given it a private key or in a member account, you'll see here's my ABI that came from my smart contract. So that automatically got injected for me. I didn't have to paste anything. I didn't have to do anything over here. I showed you how you could do that manually, like if you were over in the IDE, went into the build folder and pulled it out yourself, but you don't need to. We do it for you. We also bring in the contract address that you passed over. We also bring the function we're talking about here, which is the set function. And then this is basically taking the value out of this. So this is going to export this new value, and that's where it's going to show up here as new value in this. A couple other things. So there's been some recent changes to our ABS, our Azure Blockchain Service. And these things are by default are optional, but you'll need to pass them, right? So you'll have to set your gas price to 0, and you set your gas limit to something really high. I just always set mine to 4.7 million. But that'll easily take care of it. To geek out a little bit there, what gas price is about is, inside this smart contract, when we call this set function, there's actually a bunch of instructions that are going to happen as part of that set instruction behind the scenes. Think of it kind of like assembly code, like all the instructions that are actually going to happen inside the Ethereum virtual machine whenever that executes. And Ethereum basically will look at how complex those calls are. Like there might be a store call for you to store a state value. There might be a read call for you to go read some state or something like that. And it's going to basically tag a tax to each one of those. It's called gas, right? And so basically it's going to come up and say the complexity of Cale calling this set function is this value. Let's just make a number up and say it's 10,000. Then basically what it's going to say is every time someone calls it, they have to give me at least 10,000 gas in order to execute this thing. But that's why we set these values over here to this. Usually we don't have to deal with that, but with Quorum 2.6 that we just pushed, we have to start adding some of that stuff up there. So that's something to watch out for if you're using Logic apps. Otherwise, you'll get kind of weird errors coming back saying either gas limit issues or it's failing to find the contract, things like that.
Okay, that's a super helpful tip. Thank you.
Cool. And then the last thing is you'll just get the output here, so you'll just get the result of whatever that execution was. Now, so we got this all set up. What do we do with it? You could click run here, but that's not really helpful because we need to pass a parameter in and things like that. So what I do, and I'll show you this, you can use Postman, which a lot of people use. But if you're a VS Code guy, and you're already using VS Code for this, there's an extension out here. It's called REST Client. And you can go download this. It's free. And basically what it allows you to do is basically define an HTTP post call or a GET call or anything over here. And you can do it directly from inside the IDE, so you don't need any other tools. So in my case, I'm just going to do a post. And where I got that from is here. You can see we're doing an HTTP post, not a GET. And then I got this URL. Where did I get that? I got that right here as well. So I just copied that directly from out of here. And then at the end of that line, you'll basically have to put this HTTP 1.1 so that you can basically the version of protocol you're calling. In our case, we have a parameter. So we basically pass in a content type of application JSON. And then we just pass the JSON in. So in this case, a new value of 42. But we know it's 42 already, so let's change it to 21 for arguments. Then I just hit Control-Alt-R. That's the key sequence to execute these things inside of here. For those with eagle eyes, you'll see that there's a little waiting thing spinning down here in the bottom corner. And that was basically doing that REST call. So you can
nice.
see here.
I don't think we could see that actually, but yeah. All right, now we can.
Yeah, it's a little progress thing. It's if you think it's like, hey, did it do anything? Like what's happening? Just look in your status bar. You'll see a little spinning wheel if it's still executing. But basically, here's the raw output that we got back from that logic app. So we got back a 200. That's good. So things worked. We got back a transaction hash, which basically told us, yeah, it submitted a transaction, and that transaction needed to be mined. Now, we don't get the result back here right away, right? Because all we did was say, hey, change this value to something up there. What I wanted to show you, now we could create another logic app to read it, and we could use this get function to do that. But let's make sure that we're being honest here, and let's go check it directly. So I'm just going to use my console here that I used before, and we're going to go read that value, and you can see it's now 21. So this proves, I'm not just using my logic app so I could like hide and fake it or something like this. This read directly from the blockchain. The logic app read directly from the blockchain, and they both came up with 21, which is what it should be.
Right.
So I'll pause there. I don't know if there's any questions.
Very cool.
Meaghan, I've been talking for a while here.
Yeah, I think that was a great way just to see how to wire this logic app up. I think we just learned, I learned a cool new extension I didn't know about, this way to make REST API calls directly here. So I think it's nice to kind of see how instant that was to call this get function and then kind of get that new value that we had just set. So let's see. There was a question. There's just one question, and feel free to keep the questions coming, folks. Would this logic loop be able to handle event handlers and error code? I'm trying to find something that can sort of act as an intermediary or verifier for data flowing from Excel workbooks into some kind of database. So yeah, I think the question is just like understanding like what kind of event handlers or error handling that you might be able to integrate into a logic app.
Oh yeah. So these things are really cool. So we'll deviate here a little bit just to show you some of this, but basically this is not blockchain specific. It's just logic app specific. But you could here in your response add a parallel branch or add an action, and inside of here you can do all kinds of things. So for instance, let's say when we call our smart contract, we expect that transaction hash to come back, but we expect something about that transaction hash. Let's say we don't get a transaction hash back, something failed. We could essentially wire in, and I didn't plan this ahead of time, but we could plan in like control functions here, which will basically do things like conditional checks. And in a conditional check, it'll say, hey, if this value, and up here is where we define what that value is. So we expect a 32 character with a 0x in front of it to come back. We could basically put conditional logic here to check for that and say, if it's true, do this, which is this add action. If it's false, do this. And either way, do this, kind of thing. So you can build these. This is really like a if this, then that type interface. So you can build all kinds of like complex stuff. And there's no code here, right? It's just that's why it's a no-code tool.
Awesome. So then it would be pretty straightforward to kind of wire this up to say, like, if whatever happened to the call to that smart contract function, if it failed, then like retry this, request or do something similar, right?
Yeah, and by default, you'll get some functionality. So let me break it to show you something. So let's say we change the address to something that's not real. Let's try that for a second. And then you'll see what happens on the REST interface. So I just changed that to a contract address that doesn't exist. And if I make this call over here, again, I don't know if you can see it, but it's spinning right now. It's trying to call that.
Gotcha.
Actually, that one went through. How did that go through?
Yeah, we did get a
Maybe
200 back.
Maybe I changed the wrong logic or didn't flush. Give me a second here. I think this is the one that's calling. Let me double check. Oh, maybe not. 35D, let's see. Oh yeah, this is a different one, I think. No, it's 35D. Sorry guys, I'm doing this on the fly. I'm trying to break it.
All good. This is all the part of live demo is that is fun and unexpected.
Yeah, so this is 2FA. It should be correct. But I don't see, maybe it's caching it up here. We could try something else. Let me try that once more just to see if it was a cache thing. Because what I could do also is just like not pass a value to it, do all kinds of other things to break it.
Okay.
Yeah, looks like it's caching that one, but let me try this one. Give me 1 second here. I think it's caching it, and because that contract still exists, it's going to keep using that one, so that's probably why it's giving me that. But let's try this. I don't pass a value, which it expects I have to have a value, so this should definitely break. I just wanted to give you a sense for like what comes back in the REST interface here if you pass the wrong parameters or you're, for some reason, maybe the blockchain service is down, like let's say something happened there. So you can see this one's taking much longer. We'll give it a little bit here. It'll eventually time out and give us an error back. But while it's doing that, I mean, the core concept here is you could take this this URI and add it to the configuration on your file, like your application or even something like an Office product like Excel somebody mentioned a minute ago. You can actually take Excel and communicate directly to a blockchain, because in Excel you can write an add-on that basically calls like a web service, like a REST call. So you could have Excel with a button in it literally go pull data from a blockchain. I mean, that's pretty freaking cool, I think, that we have these tools that you don't have to write any code. You can deploy this thing up to a blockchain and you can have Excel communicate with it without writing code. Pretty cool.
Yeah, it is very cool. I think that there's just so many options, so many of these different connectors, right? But yeah, I think it's cool that that is an option to just to kind of like publish all these events to whatever downstream, products or services that are available there. So like I think Office or Power BI or anything is like a great option there. Not anything, but there's lots of great connectors.
Yeah, so here's the response of one that fails, and this is where you'll start to like go, what does that mean? Because you'll see things like, basically there was a bad gateway here, and you'll see no response from the server, and you're like, what the heck, this logic app's down. One way you can troubleshoot these things is to basically go back here to your logic app, go into your logic app into console here, and you'll see all the runs that have happened. So this is all the details of stuff that's called, and you can see one was done here a minute ago at 12:39, like 3 minutes ago. It failed. And when you click on that, you can come in here and see the actual run, and you can actually see which piece failed. So you can see this one succeeded. It was like, yeah, whatever. You didn't pass me anything, but I don't really care. So it didn't have anything to pass forward, but there was no constraint on it, right? So, oops, I'm sorry. We're jumping out of there. Sorry about that.
Okay.
Basically, it failed here, right? So you can see the little red sign, and you can look down here and start to troubleshoot like what's going on. In this case, it's still a little hard, but you can see that it says object reference not set to an instance of an object. Still not super clear on like, hey, you forgot to pass a parameter into here.
Right.
But it can give you some like leads on it, because you could say, well, where's the value that was coming in for my set? Oh, there wasn't one coming in for it. What's my gas limit set to? All those pieces. You can see all these kind of pieces in here, and you can go correct that then so you can make it successful.
Right. So you still have to do some digging, but I think this is one of the things that I really appreciate about Logic apps is when I try to build them and something's going wrong, at least you can kind of look and see what step of the app that it's actually failing at. And then you probably still have to do a little bit more investigation there, but that's kind of a great way to troubleshoot.
Yeah, and just to say, like what we talked about earlier there about like Azure Functions. So in Azure Functions, obviously you wrote all the code that's doing what the Logic app's doing here. So in that case, you could log to whatever you want, right? You could log to another table and you could go check that. So you have more flexibility there, but again, more responsibility. Cool. So yeah, that's pretty much it on calling one. Was there any other questions, Meaghan? I just want to give a sec if
there were not any other questions. So yeah, I think we're good to go.
Awesome. Okay, so I got some other ones up here. I generated, I'll just pop to VS Code for a second. I also generated this messaging one, the event one. I'll show you what that looks like. It's slightly different prompts for you. So you would just go into this event one, and that's if you're interested in, hey, every time a certain event gets called, I want to like do something with it. Again, we ask about Logic App and Flow Apps. This one doesn't fit with an Azure function, so that's why that's not there. We can put an address in here for this. Like, as me walking through here, I'm just not going to put an address in because it's just a demo. Mm-hmm. Then I would pick, like, my subscription. I would pick my resource group. And then it's going to ask me for a topic name. Because it's an event, it has to do something with it, right? So it's going to say, okay, an event was raised. What do you want me to do with it? By default, it's going to go to an event grid. So it just needs a topic name. So let's pop over to the portal. We don't do that dynamically, by the way. Sorry, go back here. We don't do that dynamically. One thing, and I'd love to hear some feedback on this, should we invest the time to make it so you can create the event grid right here? We could totally do that, but we just haven't done it yet.
Yeah, that could save some time. I mean, and kind of keep you in the IDE, I guess.
Of course, yeah. So like here, we would have to come out and type event grid topic. And again, event grid topics are kind of like Logic apps. When you go to create them, I'll show you it's like ridiculously simple. They're even more simple. You basically give it a name and a location. That's it. Subscription and resource group where it's going to get deployed. That's all you have to do to create one. I have one created here. This one right here, so we didn't have to wait. Again, they're like spin up in seconds. Everything's super cool. So once you have it, this is all you have, basically. There's not much here for you to configure. You basically have an endpoint here that you can essentially send events to. And then you have some access keys that allow you to basically authenticate to send stuff so people on the internet aren't sending events into your stuff. Basically, come back over here for a second. If I would have clicked OK there, after a few seconds, it would generate this, which looks very similar to what we did before. This window is tailored for the events. I would copy this guy. I already did it over here, so we don't have to go through that again. But I will pull up the designer so you can see what's going on here. So this one starts with a smart contract. And again, it has my ABI by default. If I would have pasted that in, it just automatically reads it. It gets also my smart contract address. It gets which event we're interested in. I only have one event. It's called stored data changed. And then you basically put in here, how often should the Logic App platform go check this? Keep in mind that Logic Apps, you basically are paying on a per use basis. So by default, when you create like a Logic App, there's no charge, like there's nothing happening. When it runs, let's say it runs for 2 seconds, then you just pay for that 2-second time, like a very microtransaction to use Logic Apps. That's what makes them appealing, right? So there's no VM running there, there's no container, so you're not like consuming resources for nothing. It's a serverless product. And so essentially, if you have a function that takes 3 days to run, obviously you're going to pay more, right? Because you're consuming more compute as part of that. So this would kind of depend a little bit on costs, like how often you want to check this thing. Obviously, if you want like high fidelity and you want to know like every 2 seconds that this happened, sure, you can do that, but you're going to pay more, right? Because you're calling this function more times. So it's something you can scale, and you can set it you can even have it monthly. Like you just have this run once a month, to do stuff, or you can do it on a per transaction basis. You can also call these. Like you could put an HTTP endpoint in front of this and say, every time I call this HTTP endpoint, go check to see if there's events. So you can do all kinds of funny things inside here.
Okay, yeah. So a lot of flexibility depending on like how often that you want to call this smart contract. Since you are paying as you go. That's good to know.
Yeah. So that handles the smart contract side of it. And then essentially it's going to basically give us back the event data from this event name that we picked here. And then basically you'll have like an event grid. Again, remember when it asked me for the topic? That's where this guy got connected in there. And he's going to pull back the body coming out of that smart contract that gets out there. And it has some identifiers and an event timestamp and all that kind of thing. Now, remember I called that a little bit ago here around 12:30. Whenever we called that first one to set the value back to 21. This tried in the background because it was already sitting here running, and I told it every 30 seconds check for it. So you can see this success that ran here, and I could trigger it again so we can like prove that it's actually coming through. But you'll see, remember, I changed it from 42 to 21. So there's the old value, there's the new value. For those who were paying attention over here, our event had the old value, new value, so that's where it picked that up from. Basically proving that it worked, and it came out here to, here's where the input was, 4221. Then I could choose, again, this is just a base. So this gives you basically, now it's in event grid for you to consume. You could hook up CosmoDB. You could plumb this into something else. You could put conditional logic after that that says, hey, if the value ever gets set to 21, then do this thing, right? And to do that, all I would do is just add an action after this one in order to do that. I'm in the run detail, so you can't see it here. We'd have to go over to the definition, which would be here.
Awesome. So that was just demoing the one event that we have in that contract. So let's say that there are multiple events. Would it make sense to kind of, do something when a specific event occurs? Like, would it make sense to kind of do that in a separate logic app, or like how might you handle multiple events that you kind of want to do some actions with?
Yeah, so this kind of gets back. It's a great question because it kind of talks about BDM and logic apps. So logic apps, you can see that we can only set this to one event at a time.
Right.
Which basically means exactly what Meaghan just said. So if I have like 10 events in my contract, then I'm going to have 10 of these logic apps running out here that have different logic. If I use BDM, I create applications over there, right? And in that case, I only need to upload the contract once. Right, so instead of having 10 definitions for logic apps running, I just have my contract definition, and I give that to BDM, and BDM will say anytime the state changes or an event is triggered, it will automatically put that stuff in the event grid for me. So again, it's like, what are you trying to do? If you're trying to do something really kind of quickly and building your application with it, logic apps are great for that because BDM requires, some setup and all that kind of that goes along with it. It also costs more, right? Because that thing's running persistent all the time, watching for those things. So it's kind of like, what are you looking to achieve? And you can use logic app or BDM.
Okay. Thanks for that, Cale.
Sure. I think that kind of wraps what I wanted to show around logic apps, or basically the serverless technology inside of here. So just keep in mind, it's on the SOL file, and you basically have all these options. We actually, I think Meaghan has it in the links, we actually have documentation for each one of these, walking you through each one. So it's kind of like screenshots and all that stuff, so you can use that. But feel free to play around there, and also obviously give us feedback if there's something you would like to see there, or something didn't work the way you thought it should.
And where is the best place to share feedback about any of this? I can drop a link in that I have for just like a list of resources, but are you talking about like a specific GitHub repo, Cale, or some other way to give feedback?
Yeah, that's an interesting question. So the logic apps are not open source, and it's not because there's some proprietary stuff inside of there. There's nothing really proprietary there. It's just the publishing model for logic apps. Like, you could publish a connector. Anybody on this call could. There's a little marketplace you go up to, and it's free, and you can publish other connectors up there to do stuff. We're just like a consumer of that as Microsoft. We just don't share that repo publicly, but the feedback would come through our forum. So we actually have like a Microsoft Q&A platform, which is like our new forums, and there's like a blockchain category there, so you can just drop it in there. And Meaghan, if you don't have that, I can get that for you.
Yeah, I do have that link. Let me bring that up and I can share it here.
Okay. Yeah, and we're the developers, like the engineers on the blockchain team, specifically for the blockchain category, we're plugged into that. So anytime someone posts something over there, we get pinged about it. So it's a good way to get feedback that's not GitHub.
Gotcha. Good to know. And yeah, I just posted that link in there. So there were a couple other questions. Let's see. The most recent one was about developing with Logic apps, and does that require Azure AD access like Blockchain Workbench does?
No, does not at all. But this is a great question, by the way, because a lot of people ask this. For instance, let me go into the first ones. Remember, we created this logic app here initially, which will allow us to call a smart contract function. Now, you'll notice there's no authentication on this endpoint. Anybody in the world could call. You guys on the call here right now could call this and cause havoc in my system. But basically, anybody in the world, is a publicly accessible endpoint. So what you could do is you could put basic auth on here and require people to log in order to do this. You can put OAuth on here. Again, it's just connectors, right? So you're going to add another connector on top of this. Some of these are set through the settings. So when you come into like an HTTP here, you can basically control different things around like secure inputs, secure outputs. There's a bunch of other trigger condition stuff in here. So there's a whole lot of things that you can do there, and you probably want to do for like a production type application, because we just wouldn't want anybody posting stuff up here, right? So it's a great question, you know.
Yeah, great question. Hopefully that answers it, Jeff Reactor. Let's see, there was a question earlier from Moshiko777. Do you still use the this keyword in the C# constructor? I'm not completely sure what that's referring to. And I think the only time I saw you use this constructor was possibly when you were actually calling the functions in VS Code in the terminal here. Were you using that there?
I was not.
Actually, no, you weren't. Okay, Moshiko 777, let us know if that's still a question or you want to kind of clarify it anymore. I'm not sure exactly what that's asking about. All right, and I think that's it for now, Cale, for the questions that we have. So maybe we can move on to talk about debugging contracts a little bit.
Yep. And just to close that out, by the way, you can delete these things if you want to. It doesn't hurt anyone's feelings or anything. You can basically recreate them on the fly, so the code generator will continue to work. For instance, if you change your smart contract, you'll want to regenerate the logic app because it might have new functions in it, all that kind of stuff. So feel free. There's nothing in stone here. You can just delete these. I'll leave it there for what we're doing now. But yeah, I talked to Meaghan about this. I wanted to talk a little bit more now about some of the debugging features because, when I was getting started with this stuff with Solidity, one of the things that it was confusing for me. I came from, I write all kinds of different code, whether it be something JavaScript, like Node.js type stuff, whether it be C++, or even something managed like C#. And I was used to like a debugging experience where I could like set breakpoints and I could like check stuff. And in the Ethereum environment, it's much different, right? Like you write this code right here, but where it's actually being executed on is some remote server somewhere. Like if you're using Azure Blockchain Service, there's nodes running up there. And when you submit a transaction to say, call this function, you're basically like signing a piece of data that says change the set value or call this set value and pass this value in. And the EVM will receive that transaction and say, okay, he wants to do this. And then it will go execute it on the EVM. It will get the output, and then it gives it back to you. That's why you saw when I did the logic app, I just got a transaction hash back, because basically I had submitted it to the EVM, and he said, yeah, I'll get to it in a second. Just leave me alone. Whenever I get time, I'll look at that, and then I'll give you back the response. So that's what you got to keep in mind. It's not the same as like an executable running locally on your machine. It looks like that a little bit when you're using this because of the way we did the development emulator. In coordination with Truffle, we're using Ganache under the covers there, which basically does that emulation for you. So if you deploy to a local development environment, which we'll do here in a second, and you interoperate with that, it looks like it's instant, but it's still, there's a node running there. Like it's basically just emulating an Ethereum node. So what I wanted to show was like when you interact with these contracts, and I've been doing it because our smart contract interaction was broken, but I've been showing you that stuff through there. But let's change this to a new value, right? And I want to show you something cool here. So if we call the set function manually here, and let's say we set it equal to 100. And actually, maybe what I'll do let's do it local because it'll just be a little faster. Let's do that. So I'm just going to right click on here, do a deploy. I'm going to deploy to my local dev environment. Usually we don't like remote debug on Azure Blockchain Service because it's just slower and it's easier and faster to do it locally here. So we've deployed that. If you don't believe me, you can go in your output window and you can see the deployment that happened here. The easy way to tell if it was on the development network, you'll see the network name up here is development, so we know we're on the right network. Everything's cool. So again, we'll do a truffle console. Now, if you're doing local dev, you don't have to pass that network stuff, right? So you can just say truffle console. By default, it will use the development network. So you can see we're in development right here. It puts that nice little thing there. And then we'll just do a simple storage. And let me show you, because I mentioned it earlier. If we do a get on here, we should get 7, right? Because that was the default in the constructor. And again,
Cale, can I stop you for just one moment here? There was a question to just talk a little bit more about the EVM in particular and what that means. I don't think the acronyms or like the meanings of these things are clear to everyone, but
Sure.
what those are exactly.
Yeah, so let me jump back over to an Azure screen because it might make it easier to tell about that. And let's go into our ABS. Sorry, I'll have to filter this. ABS. And here's my ABS deployment. And inside of here, remember I was talking a little bit ago about transaction nodes. And you can see I just have one. This is my public key for private transactions. This is my DNS name. So basically, this is a virtual machine running out there, which basically is running the Ethereum protocol. If you wanted to run this yourself, you can go download the Ethereum client. It's called, one of the most popular ones is called Geth, stands for Go Ethereum. And basically you can download that. I can show you really quickly where to go get it. You just go to geth.ethereum.org. Again, Go Ethereum, that's why it's called Geth. You hit downloads and it will detect which operating system you have, Mac, Windows, Linux. And then you can download that binary. You can run Ethereum nodes directly. Like you could do that on your local machine and you could interoperate with the IDE and do all kinds of cool things. What the EVM is basically it's a service if you think about it from a high level. And what it's doing is offering up an RPC endpoint, which is like how we communicate with it. And it will receive transactions. It will do the mining operation for you, depending on how you have it configured. Now, for up here in ABS, like as part of our Azure Blockchain Service, we have one consensus algorithm. It's called Istanbul that we're using. You can go read about these details, but there's different consensus algorithms. And what that means is like if I had 3 or 4 nodes on this network, basically the consensus algorithm is what tells it like, hey, I need at least 3 of these 5 people to say this is correct before we say that this is actually committed to the blockchain. So again, ABS is kind of hiding those details from you. If you want to go geek out on it, you can kind of change the consensus algorithm to different models like POA networks, and there's a bunch of different ones. And you can kind of play with that. But beyond that, think of it just like a virtual machine that's running some code that accepts transactions. It executes those transactions and gives you back the result. That's really, and EVM stands for Ethereum Virtual Machine is what it actually stands for.
Thank you, Cale. That was very helpful.
Cool. So back to VS Code. After I fumbled around there and wrote the right code here so you could humanly read this, you can see it's set to 7, which is what we expected it to be set to. Now, again, let's set it to something else. So let's set it to something big, 10,000. Now, what you'll see when you're doing this kind of low-level stuff is you're going to see a bunch of like cool stuff come back here because, again, it's asynchronous. Essentially, when I call that set function, I don't get the result immediately because remember I said I have to submit it to the VM and say, please VM execute my code and give me the result back. And he's going to say, okay, I'm ready to do block number 31 in this case, and your transaction is going to be included in that. And so like something interesting, again, for the geeks in the room here, this logs that comes out of here. Because there's an event here, there's a log. This is the actual event that got triggered there. You can actually see that because you can see the stored data changed here. So this is basically low level, like the Ethereum transaction that happened as it got submitted to the chain. Now, let's say, for instance, I was like, that's kind of weird. Like something was weird. Like I didn't think the result should have been 7 in this case, or 21 or something. So I want to debug it. I can basically go in here again to my command palette. Whoops, just in case someone just joined, you can go under View Command Palette, and you can type in blockchain. You can say Debug Transaction. Now, when you do this, what we're going to do is go look at the most recent transactions you've done inside the IDE. We're going to basically give you the transaction hashes that go along with those, in case you know you can memorize like 300 characters here or something. It's just that. Now, really, if you just have an identifier you're looking for a transaction hash, you can see it. We also go look at what function you actually called. So remember, I just called the set function. So let's take that. It's the most recent one. And then before that, I did a migration because remember, I deployed it. Before that, the constructor was called. So there's a bunch of things that happened there. But if I debug this one, what's going to happen is it's going to open up in the IDE here. And basically, you can see I'm actually executing the contract right now. So I'm sitting at simple storage. You can see that our variables window got filled out. You can actually see the instructions. I hope you can see this. I don't know if you can see it, but let me try to drag it up here a little bit. You can actually see the Ethereum Op Codes, they call them. Remember I was talking earlier about like assembly code and how we calculate gas? You can see all that stuff here. You can actually see the gas costs. Remember I was telling you about gas and all that? So if you're, this is a little bit more relevant for public developers because gas costs money, right? So in the public Ethereum world, if you want to submit a transaction, you have to pay for it, which is kind of the whole model of like how this world computer works. It's a microtransaction. But if you're writing smart contracts, obviously you want your contracts to be optimal, like cheap, for people to execute them. So this is really interesting that we can step through here. And basically, I'm just going to use my standard keys. So there's a bunch of keys to do this stuff. You can hover over these to see what they are. But I'm just going to jump into this function. And you can see, hey, when we called this contract, we actually called this set function. And if we space or tab down here a little bit, we hover over this, you can see 10,000. So this is the value we passed in. Remember, we passed in 10,000. We can also look at what was the current value of the stored data. So if we come down here just one more step, whoops, you can see our previous value was 7 if I hover over it, which is true. That's what we were doing. So this gives you a nice way to kind of like step through your code, see if you have anything wrong. Now, and especially if you have like complex smart contracts where maybe you got an endless loop happening, you'll get all kinds of weird responses out of the EVM when those kind of things happen. It'll be like insufficient gas, or you'll get the most famous one from EVM is always like VM error. And people are like, okay, that's helpful. Like that doesn't tell me anything. So, but if you get those kind of errors, the best thing to do is like jump in, start debugging it, and step through your code and see like, okay, where did it fail at? Oh, it's going into an endless loop over here. I didn't know about that endless loop, and then you can fix it.
Awesome. This is good to know. And I mean, you're able to have this debugging functionality that it just comes with the blockchain development kit, right?
That's right. So what we did is basically wired the debugger into all our interface here. So again, you can set watch windows and stuff in here. So if I take and let's remove that one. These are just like watch expressions. So I can put stored data here. And you'll see it gives me back 7 right now. And then if I basically tab down through the code, eventually, there we go. Then you can see it changed to 10,000, right? So
Sweet.
Full experience for everything. This is context sensitive, so when I did that thing, you can actually see it was on a push 32 op. It cost 2 gas. Here's how much gas I had left because I passed it in. You can see obviously the stack and the storage that goes along with EVM. In this case, I don't think there's anything going on. Yeah, there is actually 2710, whatever that is. But yeah, it's awesome, I think, to help debug.
Yeah, I think so too. And I mean, it's just necessary to debug your contracts, to test your contracts thoroughly, especially during development when you're not, not actually using any of these real resources, and especially being able to find out these problems before like you're, deploying to more of like a production like or public network. That is crucial.
Yeah. Yeah, and the feedback we've got on this is like public developers actually like this even more than enterprise because if you make a mistake with cryptocurrency or a DeFi or something like this, it could cost a lot of money. And so, yeah, they're very scrutinous over their smart contracts and how they execute, and if there's any bugs or loop or problems,
Yeah,
and again,
exactly.
You can just use the standard controls to stop debugging when you're done. I wanted to take 2 seconds and like talk a little bit about like what's happening in the background because it looks a little bit magic there. It looks like I basically just ran that smart contract. What's actually happening is we're replaying the transaction in the debugger. So that transaction already happened on the blockchain, and maybe it gave us a good result, maybe it gave us a bad result. When I went into the debugger here, what it was doing was going to the EVM and saying, hey, what did you run for this contract? And it was like, here's the thing I ran in that transaction, and we're basically replaying it live here inside the debugger. So it's pretty magic, like what's happening there, but it's essentially replaying the transaction.
Very cool. Thank you for breaking that down and kind of just explaining what's happening in the background. There was a question that came up. Can you write test for contracts? And the answer is yes, and that you definitely should write test. I don't know if you have any test here by default, that kind of maybe, but yeah, you definitely should write tests. You can write them in Solidity or JavaScript. It is kind of up to you. I was trying to look for the documentation to kind of explain more about that.
Yeah, if you want to write these, again, Truffle's a framework we lean on for a lot of our different things. OpenZeppelin as well. I'll just show you the Truffle one, but there's also OpenZeppelin stuff to do this as well. If you go under docs up here for Truffle, and I can post a link here in a second, right, Megan? Maybe you can grab it.
Oh, that's what I was looking for. Okay.
Yeah, and this walks through all the different things that you can do there for like how you set up your tests, all those different things that are in there, and you can see writing tests in JavaScript or writing tests in Solidity. JavaScript being Mocha-based stuff, which is what I just showed on the screen here. These are Mocha-based tests, which essentially like get your contract instance, and then basically you can pass stuff into it and do validation on it. In this case, we're asserting this is for the Hello blockchain. So if you do the Hello blockchain new project, you'll get this by default, so you can use it as kind of a template, if you will.
Right. Awesome. Yeah, that's good to see. And I think generally you want to make sure that you're just testing all of your functions and kind of like any, expected or even possibly unexpected behavior that you might experience.
Awesome.
Cool. There was just one other quick question. Does Microsoft Teams use VS Code as an official IDE? I don't know if there's an official answer to that. I would say that most developers at Microsoft probably use VS Code or Visual Studio.
Yeah, I don't know for sure, but VS Code also, or Teams, Microsoft Teams also has like a plugin architecture, so you can build other things for it. I'm sure people are building stuff in VS Code over there. I don't know about the core team though. Yeah, I'm not sure. Cool. Yeah, the other thing, I know we're a little bit over, I don't know what the time limit was here, but we're like
yeah, we're good on time.
Yeah. One other thing I wanted to talk about, and I talked about this a little bit the other day, was around wallets and the IDE wallet and these kind of things. There's also a wallet out there called MetaMask, which gets used quite a bit. I think Megan actually showed it in one of her demos, if I remember right. And I just wanted to touch base on that a little bit about like some of the details, if we can.
Yes, go right ahead, Cale. You have time, plenty of time.
Sure. So basically, for those who didn't join the session the other day, what we're doing behind the scenes, and you can do this as well with a simple JavaScript application, is basically we're grabbing the Truffle HD wallet provider. This is actually an older version. There's one with an @ now. Truffle went to a mono repo. So basically, you can go grab that. The only reason we use Truffle is because they put an abstraction on top of it using this Mnemonic to basically feed it in, and then we just feed it in as a file system object into Go there. But basically what's happening is you can see that in Truffle itself, when we do our deployment inside VS Code, there's basically a provider that gets defined here. And in our case, it's the HD wallet provider, which links obviously to Truffle's. Someone was asking in one of our previous things, like, what if I want to use a different wallet for that? Like, there's different companies out there. There's one called Portis who does this pretty well. There's one, MetaMask, we mentioned before. There's hardware wallets like the Ledger wallets, the Treasure wallets, all these different things. Each one of those basically is just a provider that implements that, right? Now in VS Code, it can be a little bit tricky because there's some constraints over like how much we can do here from a hardware perspective. So if you want to use a software-based wallet like Portis or something, you can essentially, let me show you what their docs actually look like real quick. It's super simple to kind of, I think it's Portis. were just acquired by Shapeshift. So maybe that's what's going on. But sorry, maybe I shouldn't have jumped out to Portis. This one right here. So this is the Portis company, and then and then you can go into the developer docs for this. But basically, just to show you that this stuff's so simple to set up, it's really about, you can see in your JavaScript code, when you initialize your provider, in this case you would initialize to this Portis by importing their library, and then in their kind of app ID, and then you pass in which kind of blockchain you want to talk to. Portis works with ABS and everything as well, so you can just pass that RPC endpoint in, and then it knows how to initialize that piece, and you basically pass it in as a provider. So in VS Code, I could do the same thing. I could initialize Portis inside of here and basically pass in the provided parameters, and I could use Portis directly from inside the IDE. Things like MetaMask are slightly different because they run inside the browser, right? And while this is Electron, like VS Code is basically Electron under the covers, it's not a full browser experience, right? So it doesn't have the same DOM objects and all that kind of stuff that a browser has. So if you're trying to use MetaMask or something from inside of here, you'd have to write a little wrapper. I'm not sure if anybody's done that yet, and maybe we should do it. I don't know. But their stuff is very tailored to the DOM for a browser, and so it won't work directly inside the IDE here. But if you were building your app, like this is just an IDE thing for you to deploy your contracts, you could create your own like React application or Angular application inside of here. You could totally use it from there because it'll basically fire up the browser and the DOM object to use that later. But what I wanted to get across to people is it's all about this provider string that you're passing in. So if you want to experiment with the IDE with like hardware wallets and all kinds of different things, try it out and see what works, and even tell us about it if there's something we should do. But basically, you can initialize your providers in there. If you're using a browser, obviously, the sky's the limit there for most of the wallets that are out there. Yeah, that's really all I wanted to talk about with that. To talk about the wallet piece just a little bit, to tell people this is how we're doing it. This is how you can inject it into your app. The other premise there, by the way, is like we don't want to like create something where it's like hard for you to deploy it out to like production, right? So if you're building your app in an IDE, sometimes you hard code passwords and do things like that to get your app running. But you could do the same here, right? We could have this mnemonic in here, but when we go up to production, maybe that thing is stored on a USB key, maybe it's stored in an HSM or something like that, and we can easily inject another provider into our application. So this way we're not locking people to say, oh yeah, once you build it on the IDE, you have to change all this stuff when you go into production. It's all configuration driven. It's like, give me the provider you want for production, now use that one.
Awesome. Thanks, Cale, for kind of just explaining the different way that you can kind of switch out these different wallet providers and kind of showing a couple different options here. There was one question about wallets and private keys. So let's say, let me see. This is from NS Teffy. They have used Meaghan, I can't say that, my Ether wallet in the past and logged in with their private key, and that is not safe. So they downloaded their mobile app and they need the mnemonic phrase. So is it possible to create the mnemonic phrase from the private key is the question. I searched and there seems to be no way, so I just wanted to confirm that you can or cannot create the mnemonic phrase from a private key.
Yeah, it's not possible. That would be like reverse engineering a password, essentially. Yeah, so that won't work. The mnemonic, if you ever get the mnemonics back for people who are using that for key restoration, there's no way to reverse engineer that. It's a one-way.
Gotcha. Thank you. Let us know if there are any other questions, but I think that's about it for the demo that we have planned for today.
Somebody mentioned, I just saw something in there about Ethereum Classic. Someone had mentioned.
Oh, okay. That was a question. Sorry, I had glazed over that. Ethereum Classic 51% attack was via smart contracts.
Yeah, yes and no, a little bit. Like the 51% attacks, typically are like you have to control the miners. So it usually hits smaller networks, right, where there's more ability for you to control the network, right? So the first piece you would have to do is have malicious nodes, right, with, in this case, the Ethereum Classic protocol running. And then essentially, so for instance, you could imagine like the Geth client I just showed you to download for Ethereum. You could create a hacked version of that, right? And you could put those in the network and basically, let's say there's, for simplicity's sake, let's say there's 10 nodes in the network and you create 6 nodes. Somehow you're able to get 6 nodes in there with this malicious EVM code on it, which basically says every time someone does a transaction, take some of the transaction and give it to this other person or whatever the malicious code is. That's basically what's happening there with a 51% attack. I don't think that was like directly just a smart contract bug. Smart contract bugs usually result in people losing money or some invalid state happening, but it's not specifically a 51% attack. So I don't think that was directly a smart contract thing, but probably something deeper.
Yeah, sounds about right to me. Well, I don't see any other questions for now. So I think we're gonna get ready to wrap it up here. Just a couple of call outs. At the bottom of the screen, there's a couple links down there just to kind of be able to access some of the resources that we shared today and be able to kind of, build on that and explore more on your own. Cale, if folks wanted to reach out to you, what's a good way? I think, are you here in the Twitch chat? Could you share your Twitch username perhaps?
Yeah, for sure. Let me just type a message here, make sure it comes through. I'm just the Windowser.
Windowser.
I think it's actually, give me a second here, I think it's the Windowser, yeah. Let me type it here. There you go. Yeah, you can get me on Twitch. My Twitter is @Windowser.
Nice.
Yeah.
That is easy to remember. And yeah, I am Meaghan Lewis. You can reach out to me here on Twitch as well @Meaghan Lewis. And I mean, I'm Meaghan Lewis pretty much everywhere on the internet, spelled like this. So yeah, I think that is about it today. Just a couple other reminders. If you do want to watch the recording, you can watch it here on Twitch, and then we'll be posting it to youtube.com/Microsoft Reactor. And that recording will be up there by the end of the week. But yeah, I think that is about it today. One last question that I have is if folks could just fill out a quick survey about today. It's just a very quick few question survey to let us know how this went. And yeah, that's it for me. Cale, anything else? Any closing words?
No, thank everybody for joining that was here today. And obviously feedback is important. So if we did a bad job or a good job, let us know. And then also, if there's other things you would like to see, maybe even topics in the future, definitely let us know. Happy to come on here and talk about anything you guys want to talk about around blockchain.
Appreciate it. Yeah, and it was just great to kind of learn some new things today, particularly around Ethereum logic apps, debugging contracts, wallets, all of that. So a little bit of a variety show today, but yeah, thank you all for joining us today, and thanks, Cale. I hope that everyone has a great day. And yeah, I think that's it. So see everyone later.
See ya.